In this video, we are going to solve the paper of Pearson Edexcel International Advanced Level IAL Friday 9 May 2025, which is the most latest paper over there. Okay, this is related to physics. Paper 1 over there from Unit 1, Mechanics and Materials over there. All right. And it is International Advanced Subsidiary or in advanced level over there. And if I observe this paper, overall, this paper is very easy because this is related to mechanics and basic paper. This is 80 marks paper total over there. So it is total marks is 80 over there. And before starting towards the solution, I will simply say here that kindly subscribe my channel, share the video with your friends, and if you feel any mistake, any question over there, kindly comment, or you need any solution of the paper, or you need any paper, you can also send me WhatsApp message, which is number is given in the profile of description of my channel over there. Okay, let's start towards this paper over there, where he is saying a cube of volume V is placed in a liquid of density rho. The cube displaces a weight W of the liquid over there. It means it is when I am putting some liquid here and some object is going to displace little bit water down here, then what is he saying? Which of the following is the magnitude of upthrust acting on that body? Then V multiply W making no sense. Volume multiply weight like that. And volume, no. Volume is not being going to be displaced properly over there. Volume multiply density. If we use the relation density is equal to mass over volume. So it is not like volume into density giving me mass. And upthrust is a force and not a mass over there. Then we say it should go with option D over there, that it is the weight which displaces equal to exactly upthrust. So upthrust is the force exerted in upward direction and weight is downward direction. And because it is feeling the upthrust, it is in equilibrium over there. So we say upthrust is equal to weight of that object over there. Okay, after that he is saying in the question number 2 MCQs over there, a seesaw is a uniform beam that balances on a support. Okay, the magnitude can rotate, the beam can rotate around the top of the support. Two children of equal weight sit on seesaw at equal distance from the support as shown over there. Okay, both are sitting at equal distance. And which row of the table describes the resultant forces and resultant forces? Okay, according to the equilibrium condition, we know that sum of all forces should equal to 0. That is right, left, up, down, all forces sum should be equal. And sum of all moments of torques like that, clockwise and anti-clockwise moments should equal to 0 if body or beam is in equilibrium. As he said that the beam can rotate around the uniform support, we comes to rest, that seesaw distance equal supports this. If they are properly balanced over there, then I will say here that the resultant moment and force will be given which row, because they are properly balanced from both sides. So their sum should be equal to 0 for cases of forces and moment also. Let's move to question number 3 here, where he is saying that the diagram shows a ball of mass m moving at a speed v along a horizontal line table over there. Okay. The ball leaves the table. The time taken between the ball leaving the table and landing to the floor is t over there. Okay. After that, he is saying a second ball of mass is 2m moves at speed 2v along the table. Which of the following gives the complete scenario of this? Okay, a second ball of mass 2m means now mass is doubled. This was original mass, and now mass is doubled. Moves at speed double means speed is also doubled over there. All right. Then he is saying which of the following gives the time taken between the second ball leaving the table and landing on the floor over there. So if we go with it, we will simply say here that the time, even though I have increased my mass, I have increased the speed over there. But here he is saying which of the following gives the time taken between the second ball leaving the table and landing on the floor over there. As I will simply say here that even though speed is doubled, mass is doubled, but gravity is going to act toward downward over there, and gravitational acceleration like that is staying same for both of the masses. Even you have doubled the mass, you have doubled the velocity, or like that, then you can say it is coming downward. Will take exactly the same time because gravity is constant. If I'm saying that the ground or soil you are taking in the form of earth 9.81 like that meter per second square like that, then we can say the time will staying the same over there. So option B will be right for it. It will not be going to double the time over there. All right. In every MCQ, I'm trying to give you the reason behind it, why I'm choosing that option over there. The forces acting on a person sitting on a chair are weight and normal force. Means someone is sitting on the chair over there, his weight is acting downward, and normal force R is acting in upward direction. Which of the following gives the reason why these forces do not form Newton's third law pair over there? A reason behind that I will say here that when we are going to take Newton's third law, there is a condition that action and reaction should not happen on the same body. Action and reaction on same body. But in this case, weight and reaction force both are acting on same body over there. So the condition is when Newton's third law should be taken, then action and reaction equal in magnitude, opposite in direction. Then the objects should be on opposite objects or on different objects they should act over there. Chair is stationary, no way. Forces in opposite direction, no way. The forces act on same object. So this condition is going to reject the Newton's second law. Reason why do not form the Newton's third law. So I will say here, as Newton's third law states that action and reaction are equal in magnitude, opposite in direction, should happen on two different objects over there. Okay, now he is saying a wire is used to hang a picture from a hook on a wall. The wire exerts the forces T1 and T2 on the picture. The picture has the weight W. Okay, weight W is downward and it is hung with the help of hook, and it is balanced not to scale. Okay, which of the following describes the relationship between the forces when the picture is hanging on the wall? Remember that downward forces will equal to upward forces over there, and in that case I will say here that what should we take here, that the weight downward will equal to the sum, because it will be this weight is being going to be divided into the tension 1 and tension 2. So I will say here that when you are taking weight downward, then it should be being taken in the form of opposite direction upward over there. And when the direction is changing, then you are saying that W weight according to closed figure, as all of these are three vectors. This is for if I'm taking weight as a downward vector, then I'm saying this is the one vector here, then this is the second vector is here, and third vector is in this form. So it is a complete closed shape in a triangle like that. What I said, look at here, I'm taking T2 as vector over here, T2, then I'm taking T1 vector over here, then I'm taking W vector in downward direction over here. Then I am saying the total sum of all of these vectors is equal to 0, and the relationship is being explained in the form of B option, where all three sides of a triangle are being added and they are taken as correct over there. So this is whenever a closed shape is formed by all of those vectors, then their resultant is always equal to 0 in that case. Let's move towards the question number 6 as MCQs over there. Around about 10 or 12 MCQs will be there. An object has a constant non-zero acceleration. Non-zero acceleration. Okay, constant non-zero acceleration. Then we can say here which is the displacement time graph, could represent the motion of an object. Constant displacement traveled means velocity is constant and the acceleration is zero, so option A is not right. Here he is saying constant non-zero acceleration. So for going upward, acceleration is positive at maximum height. It is going to be taken displacement maximum and it is coming back to its original position back over there. So option B will be fine by having non-zero acceleration for displacement time graph can be taken for this option. On the other two, this displacement is going to be shown that it is constant velocity, acceleration zero, constant velocity, and then displacement is not changing. In both cases, acceleration is zero over there. For non-zero, it should be taken in the form of curve over there. So option B is fine for it. Let's move to question number 7 now. Okay, here he is saying that the forces acting on a helicopter are shown. The helicopter is represented by a dot over there, 200 Newton upward, 15,000 downward in the form of weight. Okay, 14,500 in the form of downward form over there. Okay, what is he saying? Which of the following expression gives the magnitude of the resultant force in newtons on the helicopter over there? So I will say here, I will have to take the subtraction first. And then why should I take the subtraction? Because this is the vector form. As we know, when it is in equilibrium, then we say here that 14,500 is upward, 15,000 is downward. Take the difference of both of them, and then you will get some downward form over there like this, because 15,000 is greater than 14,500, and take the resultant vector in this format. Then if you want to go, that 200 square is always present over there, and then there is 15,000 minus 14,500 should be taken, and to calculate the magnitude of force vector, we know that we should take fx square plus fy square in the form of square root over there. Then I can say here fx is 200 Newton square, 200 square, plus fy should be taken as 15,000 minus 14,500. So this will be the form, by taking in the form of square root, will give me the resultant force over there. So this is also taken in the form of square over there. So this one is right, 15,000 minus 14,500. And remember that 15,000 minus 14,500 in the square should not be being taken in the brackets, both separately not to be taken, separately not to be taken, without square root cannot be taken. So option D will be fine for it. Okay, here now he is saying a box of weight W, okay, slides down a ramp. Okay, the ramp is at an angle of theta, all right, with the horizontal. A frictional force F acts on the box, means F is acting in the form of upward force back over there. So which of the following is the correct when the box moves at a constant speed over there? So I will say here that which one is correct? F is equal to W cos of theta. If I say, if I want to resolve this in the form of component, that this is my W, then I am taking here, if I want to resolve this, then I am saying here that it should be being taken as parallel force and this force. Okay, this is the normal force according to weight on this surface. This is on this form. This is theta. And then F should equal to, this is theta, na? Opposite side is for W sine theta. And adjacent side should be taken as W cos theta. So remember that R as a reaction force is equal to W cos theta, and W sine theta should be being taken as in the form of its resistive force in backward direction. If it is to be taken in this direction as W sine theta in the form of downward, its horizontal, its vertical component for this weight over there to be resolved by using this angle over there. Then W sine theta is equal to F and R is equal to W cos theta. Where he is saying F is equal to W cos theta is wrong because F is equal to W sine of theta. F is less than W cos theta. Now, yeah, this option will be right. F is equal to W sine theta. I want to convey you message here. The block which is writing over here, reaction force is equal to W cos of theta. And the resistive force which is in backward direction, then we will say F will equal to W sine of theta exactly to resolve the components in a proper way, how they should be taken in case of inclined at an angle theta over there. Okay, after that, he is saying that the driver of a car applies the brakes to the frictional force F between the tires and the road is constant. The average power dissipated by F is 50 kilowatt over there. Okay, if it is 50 kilowatt means 50 multiplied 10 raised to power 3 should be being taken, and then he is saying car moves a distance of 13 meter over there. Okay. Distance is 13 meter in a time of 2.3 second before coming to rest. Which of the following gives the force in newtons? All right, here I'm using the power formula is equal to work over time. Then I am using it power is equal to force multiplied distance over time. Then power it should be multiplied by time divided by s. So just put these values. Power is being taken 50 multiply 10 raised to power 3 multiply 2.3 as a time divided by the distance is 13 meter. So option A is fine for it. Okay, just try to use this formula for exactly manipulating and adjusting it into this question over there. Okay, in question number 10 now, he is saying that, all right, here he is saying a toy train of mass 3m is moving with speed v, and a toy truck of mass m is moving with speed 2v in opposite direction as shown. Okay, v is in this direction, 2v is in this direction, backward direction like that. Its mass is 3m, its mass is m over there. The train and truck collides and move off together. Okay, they are being separated out. And the move off together means they are going to stuck with each other. Which of the following expressions gives the new speed of the train and the truck over there? So initial momentum, which I can take 3mv mass into velocity plus in opposite direction will be taken minus 2mv over there is being taken as they are move off together. So 3m plus m is 4m and 4m and v I want to calculate over there. And then I will say here we should go for cancellation and addition and subtraction a little bit. Then I will say here that 3mv minus 2mv. Why I took this minus? I told you that direction is opposite because this is in left side and this is in right side over there. So 3mv minus 2mv is equal to mv is equal to 4m v dash, we can say like that. This is v dash over there. Okay, after that m is cancelled, so v dash will equal to v by 4 over there should be being taken for this option as a over there. Okay, I used here law of conservation of momentum. Conservation of momentum. All right, let's move to the next over there, what he is saying in the next section. And now there will be the structured question section B over there. All right, a resultant force of 4800 Newton acts on a boat. The acceleration of the boat is 0.3 meter per second square, and we will have to calculate the weight of the boat. So very easy. Just use Newton's second law, F is equal to ma, and get your acceleration from there. So acceleration is given, force is given. So mass will equal to force over acceleration, that is equal to 4800 divided by 0.31. Let's go towards it, where he is saying 4800 divided by 0.31 equals to this, that is 15,488. 15,488. 83. That is equal to 15,483 kg. And if I want to go for its weight calculation, then I will use this mass to weight, because he said weight to calculate, where W is equal to mg over there. Just multiply it with 10 or like that. So 15,483 multiply by 10 or 9.81. 9.81. I'm taking approximately 10. I'm giving my answer up to two significant figures, and I'm writing 15 with 1, 2, 3, and 4 Newton as the weight of boat over there should be being taken. That was easy one. Just use Newton's second law and then use the formula of W is equal to mg over there. Okay, here he is saying a person rides a bicycle along the path shown. Okay. At the end of the path, the magnitude of the displacement from the start is less than the distance traveled by. Describe why the displacement is less. Because we know that the displacement is the shortest distance of straight line in proper direction over there. So it should be less over there, straight line from the start to end. And we can say distance is the length of the path. So I can say here distance is length of the path, which is larger, length of path. On the other end, displacement is the shortest distance. Displacement is the shortest distance between 2 points. The shortest distance between 2 points over there. All right, let's move to the next part. What is he saying in this distance and displacement difference? He is saying the velocity time graph of the bicycle is riding over there. Bicycle ride is shown. All right, determine the acceleration of the person on the bicycle. Acceleration on the person on the bicycle over there. So velocity, when he is saying over there, like we will have to take two pairs of corresponding values of velocity and time graph from there. Like I am taking the gradient from the time. This one is 4 seconds, and then I am taking for this one 15 and 16 over there. Then I am taking both of these values, and corresponding speed is here for 1.8 is here, and for this one my velocity is having the value 4 5 so it is 5 meter per second. If I go for this, for calculation of acceleration, we know that we should have to take the gradient over there. For this one, I will say my point have the vertices 16 comma 5, and my this point will have the value uh 1 2 3 4 4 comma 1.8 over there. So for calculating the acceleration, I will say here that go with it with the 5 minus 1.8 divided by 4 minus 16. 5 minus 1.8, 16 minus 4. So it is 5 minus 1.8 will be giving you value 3.2. 5, yeah, 3.2 divided by 12. So 3.2 divided by 12 will give you 3.2 divided by 12 is equal to, this is equal to 0.266. So 0.27 should be being taken over there. 0.266. 0.27. 0.27. And the remaining three parts, which I have was easily going to calculate over there. Here I will say acceleration is a 0. And for this one, I will say it is slightly changing the acceleration, and it is going to again, the acceleration is negative, acceleration is positive, but with less value, and it is negative, and acceleration is also being having shown some value. So the maximum acceleration during which the graph has changed its steepness more, it is more steep, then the acceleration is maximum, which I have calculated for this section because he was asking about the maximum acceleration for it. The explanation which I have told you, you can write it in the form of statements like from 0 to like 4 seconds, it is 0. Then from 4 to 16, it is increasing at very high rate. Acceleration is increasing. And in the last section, when here it is 16 to 25, it is slightly increasing its acceleration. And from 25 to 35, you can say it is slightly decreasing acceleration, negative acceleration in that case. Okay. Here he is saying that in the game of basketball, points are scored by throwing a ball so that it falls through a hoop. Okay, this one he is throwing in the form of hoop over there. The rules state that the distance d between the hoop and the floor is 3 meter. So d between this is equal to 3 meter over there. Then he is saying a basketball player throws the ball and it falls through the hoop properly, exactly into the hoop over there. The ball was thrown from the height of 1.7 meter, means this height is 1.7 meters over there. Then he is saying that the initial velocity of the component of the velocity of ball was 5.1 meter per second. As the ball entered the hoop, the vertical component of velocity of the ball was 2.1. So it was originally V, initial vertical Vy. And this is when it enters, it is 5.1. When it enters, then it is Vy in the form of downward should be being taken as 2.1. It was launched from here, it was 5 meter per second. Deduce whether d was 3 meter, means that hoop distance was 3 meter or no, like that. Then for that purpose, I will say here that if I use the relation of third equation of motion over here, let's try that. If I'm using that one, let's try that. For example, we can say here third equation of motion, I'm using 2as is equal to v square minus u square over there. For that purpose, I'm saying 2 into minus 9.81 because the ball is going upward over there. And s I want to calculate is equal to v square. V was being taken as final velocity, that was 2.1 meter per second square, but it should be negative. And because it is the changing the direction over there, minus v u square. U square was 5.1 meter per second square. So if I arrange it, let's calculate our delta s for s over there. I will say here 2.1 square minus 5.1 square over 2 into 9.81. Let's try what is the calculation giving us the answer over there. First of all, fraction introduced. 2.1 square minus, is he going with it? Yeah, it's going with it. Minus 5.1 square, 5.1 square divided by 2 into 9.81 equals to minus 120 over 109. If I'm getting minus 9 here, then I'm saying the value is 120 over 109, which is equal to 1.1. So minus sign from the denominator is going to cancel out, so it is 1.1 meters. And if I am taking my distance according to the given this value, like this is 1.7 was given, and now I have got the distance traveled, that is 1.1. If I add both of them, 1.7 plus 1.1, then I'm getting 2.8 meters. So 2.8 meter, what he is saying, deduce whether this is 3 meter. As I know, 2.8 is not equal to 3. So I can deduce here that the value which he has given us in the form of 3 meter is not correct. Okay, it is 2.8 exactly, which I have calculated for you. Okay, let's move to the question number 14 over there, where he is saying that the brakes in a car reduce the kinetic energy of the car. Okay, reduce the kinetic energy. In an electric car, some of this energy is transferred to the battery in the car. An electric car of mass 1800 kg moves at speed of 14 meter per second uphill as shown. The driver applies the brakes to bring the car to stop. During the braking, the vertical displacement of the car is 0.76 meter. 76 meters over there. And the energy stored in the battery is increases 45 kilojoule per mole over there. Then he is saying that okay, now I will have to also involve potential energy over there, because height is given over there. So for that purpose, I will say here that calculate the efficiency using the brakes to charge the battery over there. All right. First of all, I will have to go for calculating kinetic energy. So kinetic energy is equal to half mv square. M is 1800 and v is 14 square. Let's go for its multiplication and getting the answer over there. Let's go fraction introduced. 1 over 2 multiply 1800 multiply 14 square equals to 176400. 176400 joules. On the other end, I will also have to calculate the potential energy, which should be taken as mgh. So potential energy is equal to mgh over there. So mgh should be taken, m is 1800 again, into 9.81 into height 0.76. Let's go for it for calculation. This value also 1800 multiply 9.81 multiply 0.76 equals to, this equals to 13,420. 13,420. Okay, 13,420 joules. So this is the potential energy which he has attained. So the waste energy will be converted into electric energy. So I will have to take the difference of both of them, and we will have to take the 45 kilojoule as output energy to get the efficiency over there. So I am going towards it, that efficiency efficiency is equal to output over input multiplied by 100. So for output, I said 45 kilojoule, which is converted into electrical energy. 45 kilojoule divided by input, both should be subtracted. 176400 minus 13420. So let's go with it to calculate it. He has not said to me that percentage efficiency, so I will not multiply by 100, okay? So I'm not writing it here. 100 should not be done over there. Okay, and for this one, let's go for calculation over there, where he is saying fraction introduced. 45 multiplied 10 raised to power 3 divided by 176400 minus 13420 equals to this equals to 0.27 0.276 like that. 0.27 is fine. So it is 0.276 like that is the efficiency of this function or system over there. So let's start to the next question over there. We will say here. Okay, here he is saying that a builder uses bricks to build a wall. All right. As the wall gets taller, the force on the brick at the bottom of the wall increases. Okay. A force compression graph is on the bricks is shown over there. All right. This is the force. This is the compression. Compression is increasing as force is increasing. Okay. Determine the increase in elastic strain energy in a brick as the force increases from 85 to 140 Newton. 85 to 140 Newton. So 140, 100 and 150. So every two is going for 10. So I'm saying here that 85 Newton to 140, 85. So it is 50, 60, 70, 80, 90, 100. Okay. 50, after that 60, 70, 80, 85. Okay. And then 140, 100, 150. It is 140. So during this is the point. And for this one is this point. Okay. Then I will say here that determine the increase in elastic strain energy. So I will have to take both of the areas under graph over there, and then I will take the difference of both of them so that I can get the elastic potential energy over there. So I will say here, first of all, I am taking for 140. 140, the extension is shown in the form of this. Then I will say here it was 0, 50, 100 and 150. So it is 140 Newton nanometer over there. This is nanometer. So I'm taking here for 140 Newton first. 1 by 2 into Fx. Fx. Area under graph, or we can say I'm taking, you can also use here trapezium formula over there for area under graph to get exactly the difference over there. But if I'm using the big right angled triangle and then I'm using the small right angled triangle and then I'm subtracting, I can also get the same answer over there. Okay, 1 by 2 fx, I'm using 1 by 2 into f is 140 into, I'm taking here, it was equal to exactly middle now. Middle, it is, I'm taking here in the middle of this value. So it is 90, 95, I'm saying 97. 97 multiply 10 raised to power minus 9 nanometer is cleared over there. After that, I am saying you also get the other value of your this 85 Newton. 85 Newton, then I will say here it is approximately reaching towards 50, 60, 60 is for the two numbers over there. So it is, I'm taking 60 over there, 60 nanometer over there. So I'm saying here 1 by 2 into 85 into 60. I'm taking for the smaller force over there. Then I will subtract both of them and I will get my answer over there. 60 multiplied 10 is power minus 9. Let's go for calculation and subtracting over there. What I am saying here that first of all, fraction introduced, take the bracket also. Bracket, because I will have to subtract these values now. So I'm saying here 1 over 2 multiply 140 multiply 97 multiply 10 raised to power minus 9. 10 raised to power minus 9. Then I'm using bracket close here. Then I am giving the minus sign and starting my other value also. Fraction introduced again. Okay, 1 by 2 multiply 85. 1 over 2 multiply 85 multiply 60 multiply 10 to the minus 9. 60 multiply 10 raised to power minus 9 bracket close. Okay, equals to 4.24 multiply 4.24 multiply 10 raised to power minus 6. So it is 4.2524 4.24 multiply 10 raised to power minus 6 joules increase in the elastic strain energy over there. Okay, the brick undergoes elastic deformation. What is meant by elastic deformation? Elastic means when the deforming force is removed, the body will regain its original position back. All right. So I think so your complete concept behind it is done now, and you will be easily going to move towards the next questions also. Okay. For question number now, we will have to move question number 16. Okay. A student used a falling ball method to determine the viscosity of the vegetable oil. Viscosity means internal resistance between the layers of the fluid over there. He measured the diameter of the ball bearing. Okay, diameter he has measured. He dropped the ball into the measuring cylinder and containing vegetable oil over shown figure. Okay, ball 20 centimeter, and this is vegetable oil and ball bearing. Okay. The ball bearing is reached to the terminal velocity Vt. Okay. The student then measured the time taken for the ball bearing fall 20 centimeter. Okay. Give one other measurement needed for to determine the viscosity of the liquid. Okay. He has not measured the mass of the ball over there. So here I will say here mass of mass of ball bearing should also be measured, because according to viscosity we will need that according to its formula over there for viscosity for getting the weight value over there. Okay, then he is saying the diameter of the ball bearing is 1.24 millimeter. The time taken is 20, time taken a fall of 20 centimeter is 1.3 second. The student calculated the value of 5.6 10 is per minus 5 Newton of the viscous drag on the ball bearing. Now, I will say here that calculate the viscosity. I tell you here according to Stokes' law, the drag force is equal to 6 pi eta rv. Here I will say that first of all, I will need, I have this 6 constant value, pi value, f value, where eta is coefficient of viscosity, which I want to calculate over there. So it should be remained as it is. Radius I can take in the form of by dividing by 2 over there by to the diameter, but the speed I don't have. So for speed, I will say here that distance is 0.20 meter. 20 centimeter and 1.3 second. For that one, get the speed value over there. Then it will be 0.2 divided by 1.3. 0.2 divided by 1.3. 0.2 divided by 1.3 equals to this equals to 0.154. I am rounding it off. 0.154. 0.154, 0.154 meter per second. So I have all the variables, just arrange them to get the coefficient of viscosity value, calculate the viscosity of the liquid or coefficient of viscosity of the liquid over there. So for that was, first of all, I'm making it subject. Eta is still here. F divided by 6 pi RV. And then I will say F is equal to 5.6 multiply 10 raised to the minus 5 divided by 6 multiply pi multiply r is I have to divide this because the diameter is 1.24 millimeter. So I'm taking it 1.24 multiply 10 raised to the minus 3 divided by 2. It is the millimeter form, also divided by 2 over there. And in the last, the V is 0.154. 0.15. So by putting all of these values in the calculator, let's check what he is giving us the answer over there. Fraction introduced first of all, so I'm writing it 5.6 multiply 10 raised to power minus 5, 10 raised to power minus 5 divided by 6 multiply pi multiply fraction introduced again. So it is 1.24, 1.24 multiply 10 raised to power minus 3 and divided by 2, multiply by 0.15. 0.15 equals to 0.0311. 0.0311, 0.031. So 0.032, 0.031 is fine. If you are taking round it off, then it is 0.032 particles over there. So this was for viscosity relationship over there. Now he is saying here, in the second last part of this question over there, he is saying the student repeated the experiment. He used the same oil at lower temperature. Explain how using oil at lower temperature affected the time taken for the ball bearing to fall for 20 centimeter. So I will say here that as temperature decreases, viscosity increases, because they are coming more closer towards its molecules over there. So when the viscosity increases, internal resistance increases, so ball falls at a smaller terminal velocity. So ball falls at smaller terminal velocity over there, and we can say, so time taken will be greater. So time taken will be greater. So this was the concept behind it, how we should go for viscosity to be taken into account over there. And in the next questions, we will also watch over there. And what is he saying in the next question over there, question number 17. Okay, let's start it. Okay, here he said that a force extension graph for a sample of one string is shown below. Okay, here he is saying the F and X is given. Okay, extension. Okay. No, what is he saying over here? Extension graph is given. Okay, the table below is shows the stiffness of for a sample of 3 strings on the violin. Examples are given X, Y, and Z. Okay, this is stiffness. Deduce which string was used to obtain the force extension graph over there. So first of all, I will have to go for the calculation values. Then I will say here is saying 0, 10, 20, 30, 0, 40. Okay, here he has taken 80. I will try to take my value for 80 as 29. Okay, I'm going to use the gradient basically at this point because it is a straight line, and I know that the spring constant is basically obtained by getting the force and extension graph gradient over there. So I am simply taking over here spring constant K is equal to F over X. F is equal to Kx according to Hooke's law over there. So F is equal to 80 Newton divided by, it is being taken as one value back, it is 30 and it is 29. 29 multiplied 10 raised to power minus 3. Let's check what he is giving us value. 80 divided by 29. 80 divided by 29 millimeter. 29 multiply 10 raised to power minus 3 over there is equal to, this is equal to 2758. So 2758. This is the spring constant value over there. So 2758, 2760 like that. So I'm taking it round off to be taken as, yeah, this is for option Y over there, which is approximately equal to 2700. So we will say that it is for reduced string was used to obtain the force extension graph was the string Y over there. So try to calculate the spring constant and the stiffness constant or spring constant which he has taken for the strings of violin over there. This was done for you. Okay, in the next part, he is saying the fourth string on the violin has an original length is 0.75. Okay, 750 meter over there. When the tension is applied on the string 36 Newton, the new length of the string is 0.752 meter. The radius of the string is given in this form. Determine the Young's modulus. So here we will have to take, as we know, Young's modulus is equal to stress over strain. And stress we know that is equal to force over area, and strain is change in length over original length, and over I am taking to the top of this. So I'm just putting the values over here that it is 36 multiply original length was 0.750, 0.750, and it is 0.02 will be the change in length. And we will have to take area. Area is pi r square divided by pi. R is having its value of 0.85 10 to the power minus 3 multiply 10 raised to power minus 3 whole square. Now it is pi r square is done. Multiply change in length 0.750, 0.752, 0.752, 0.750. Then if I subtract both of them, I will get 0.002. So it is 0.002 over there. Let's put all of these values into the calculator to get our answer over there. First of all, fraction introduced. 36 multiply 0.750 divided by pi. After that, multiply bracket start 0.85 multiply 0.85 multiply 10 raised to power minus 3, 10 raised to power minus 3, bracket close, whole square, pi r square is done over here. Multiply 0.002, multiply 0.002 over there, and we get this answer 59. How many digits are there? Wait a second, I want to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5.95. 0.95 multiply 10 raised to power 9 Pascal will be the Young's modulus for this fourth wire over there. 5.95 10 raised to power 9. 5.95 multiplied 10 raised to power 9. Young's modulus has the unit as Pascal, as pressure, like that. Okay, or stress, like that. Now he is saying a Newton's candle has 5 identical spheres A, B, C, D, and E. Okay, A is outside, B, C, D, E. Okay. Now he is saying these are the frame, this is sphere, string. Okay. Each sphere has a radius 7 multiplied times power 3. Okay. Density of the steel is this. Calculate the mass. So for the volume, sphere has the formula. Volume is 4 by 3 pi r cube. I will use this formula to calculate my volume over there. And then we will use the formula density is equal to mass over volume. We will want to calculate mass. Mass will equal to density multiply volume over there. For this volume, I will say here 4 by 3 into pi into 7 multiply 10 raised to power minus 3 whole power 3 over there. Let's calculate the volume first. Then it is having the value 4 over 3 multiply pi multiply r cube. R is having value 7 multiply 10 to the power minus 3 multiply 10 raised to power minus 3 bracket close. Okay, after that whole power 3 over there will give us the volume, means 1.44 10 is power minus 6. 1.44 multiplied 10 is to power minus 6 over there. Let's check again. 1.44 multiplied 10 is power minus 6. So I will have to multiply this with my density so that I can get my volume over there. So density is 7.8 multiplied 10 raised to power 3 is being taken with multiply with 1.44 multiply 10 raised to power minus 6 over there. So for this one, I will simply say here multiply 7.8 multiply 10 to the power 3. So multiply, answer is there, multiply 7.8 multiply 10 raised to power 3. And you will get the mass in kilogram, that is having its value means I can say 0.01 kg. Mass is 0.01 kg. And if I want to write it in standard form, then I will say it should go with the 1.1 multiply 10 raised to power minus 2 kg will be the mass of the sphere over there. I think so you will be calculating completely for understanding all of this. Okay, now he is saying that, okay, the angle is given. A student pulls the sphere A. So the string is at an angle of 38 degree with the vertical. All right. The student releases sphere A. Determine the initial acceleration of the sphere A when released over there. For this one, I will simply say here we will have to use our resultant force at that point. Resultant force. If you remember the resolution of components in the proper way, then I will say I will have to go for, because this is for weight over there and it is mg with opposite to 38 degree, then it is that this component should be being taken. So this one I want to calculate as my resultant force over there. So I'm saying it is having mass m, it is mg sine of 38 degree. Just by putting the values of mg over there, then I will say here that mg sine theta will be giving me same values. The mass was 1.1 multiplied 10 raised to power minus 2 multiply g was 9.81 multiply sine 38 degree. Let's check what is he giving us. Then I will say here 1.1 multiply 10 raised to power minus 2 multiply 9.81 multiply sine 38. Sine 38 bracket close will give us the value 0.06 over there. So that is the value for its acceleration. 1.1 sine 38, 9.81, and its value is 0.06. So if I am taking, because I need only acceleration, so it means I will have to divide this 0.06, what was my answer? 0.066. That is in the form of Newton force, but I need acceleration. It means I will have to divide 1.1 multiply 10 is power minus 2. 10 is power minus 2. So I am getting my answer as, let's check what is he giving us. Means this value should be divided by 1.1 multiply 10 raised to power minus 2 again. So the answer is 6.03 multiply 10 raised to power minus 4. No, it should be taken 10 to the minus 2 is there, na? So it is coming up. So it will be going to 6.6 like that. So it is 6.03. 6.03 is 10 to the minus 4 is going to cancel out, and in calculation I have taken this 10 is to the minus. If I give you the proper answer, I will have to use the brackets over here so that it can understand that he will have to completely divide the whole value. Now get the answer 0.0594 as your mass over there. So it is being taken. Okay, 0.066. Wait a second, I want to check it again. I think I have done something wrong over there. Fraction introduced first of all. 0.066 div 0.066 divided by 1.1 multiplied 10 raised to power minus 2 bracket close, no need of bracket there, is equal to 6. So it is 6 point something or 6 completely. So it is 6 meter per second square can be taken into account for getting your answer properly over there. Okay, this was the calculation which I have used. Some silly mistake was happening while calculation or using the calculator over there. So try to not to use too many steps as to move on over there. Okay, diagram 1 shows the position of the sphere. Okay, this is the position 1, and diagram 2 is showing shows that the position of a sphere A is released. After being released, the sphere A collides with the sphere B and comes to rest. Sphere B, C, D remains at rest, and E moves away. Okay, and E reaches the highest point over there. On other side, describe the changes in energy and momentum of the sphere from A and E from the time of sphere A is released until sphere E reaches the highest point. Ignore the effects of air resistance over there. So I will say here that when A is going to fall and strike towards the B over there, then I will say here that as A falls on B, then what is basically happening? Gravitational potential energy of A due to some height difference over there in this format is going to decrease. And when it is, and kinetic energy of A increases, with which it is going to collide with it. And kinetic energy of the ball A increases over there. As he said, explain in energy. This was for energy as a point that gravitational potential energy of this height is decreasing and kinetic energy is increasing. And as A falls according to momentum, as A falls on B, A ball is falling on B, then the momentum of A increases. momentum of delta P, change in momentum of A increases over there. So this is for ball A. Both of these cases I have explained for you. And during the momentum, during the collision and during collision of ball A and B, what we are observing over there, that momentum of A decreases and E increases. Momentum of A decreases and momentum of E increases. And in all of these cases, during this whole scenario, I will say that during the collision, momentum is conserved. So law of conservation of momentum, like initial momentum, P initial is equal to P final. Of both of these cases, like A is completely transferred and it is perfectly elastic over there. And kinetic energy of A is transferred to E also, and total energy before collision is also equal to total kinetic energy before collision. Before collision is also equal to exactly kinetic energy after collision. So both the law of conservation of energy and law of conservation of momentum are holding, and this is perfectly elastic collision of all of these balls. And this was the little bit explanation. Remember that this is your static question. A static question means here he will be deducing your concept behind it, and on your concept of explanation, it will be explained and awarded to you by these marks of 6 questions over there, 6 marks question over there. Okay, let's move to the next question, number 19. What is he saying over there? A student stores her bicycle on a track. The bicycle rests on a rail that can rotate about a pivot. Okay, this is can rotate about its pivot over there. The bicycle off the rack. The student okay, the bicycle rests and can rotate pivot. To take the bicycle off the rack, the student uses a handle. This is the handle over there. This is the handle over there. Okay, handle to lower one end of the rail to the ground. The piston applies a force to the rail as the rail is lowered the ground. The diagram shows the bicycle on the rack before and after the rail has been lowered to the ground over there. All right. When the rail is in equilibrium, the principle of moments applies. State what is meant by principle of moments. Principle of moments states at equilibrium, sum of clockwise moments is equal to moments is equal to anti-clockwise moments. Moments over there. So this is the complete scenario in which we can say principle of moments should hold over there. Okay. Or we can say sum of all the moments should equal to 0. We can also say like this. Okay. And after taking the bicycle off the rack, the student lifts the rail back. Okay. The student lifts the rail back to its original position. The uniform rail has the length of 1.4 meter and weight of 95 Newton. The student applies the force F on the handle perpendicular to the rail. The rail has a force of 160 Newton to the rail. The diagram shows, okay, 0.37 and 18 degree and 160 Newton and 42 degree over there. Determine the minimum value of F needed to be done over there. Okay, for this one, first of all, I will have to go for the piston force about pivot over there. That is 160 Newton like this. 160 Newton along the piston over there. And by taking the angle of 18 degree also. and 0.37 as its distance. So I'm saying here moment of piston over there, moment across, like moment across piston. How can I calculate that? 160 multiply sine 30 sine 18 degree sine 18 degree multiply by the distance is 0.37 Newton meter. So if I go for its complete value, then I will say here that it is 160 multiply sine 18 degree multiply by 0.3737 equals to, it is 18.29 or 18.3. So it is 18.3 Newton meter. On the other end, what I have for this 95 Newton, now I am saying it is on the pivot. So weight on the pivot is 95 with its horizontal component of the force, like cos 42. So moment across pivot will be taken as 95 multiply cos 42 degree should be taken with the length that it was being taken from this point to this point, 0.95. If I take here, then he is saying that the total uniform length is 1.40, and I'm taking from pivot at the center, then it is divided by 2. So it is 0.7 over there. All right. So it is multiply 0.70 meter. Let's check what the value is coming over there. What the value is coming over there. Then I will say 95 multiply cos 42 multiply 0.70. 0.70 is equal to 49.419. So 49.4. 49.4. Both the moments I have calculated over there. Now I am applying my total value which he has given for us. He has said that according to the force acting, the diagram shows over there, the student applies, determine the minimum force F needed. F is also upward, so I will take upward momentum from 0.37 meter and 160. I will have to take both upward and downward equal. So I will say here 18.3 being taken, and it should be added with force F multiply. F is with the whole distance 1.40 in the form of couple like that is equal to 49.4, which is in downward direction over there. From here, I want to calculate F over there. Then F is equal to 49.4 minus 18.3 over 1.4. I think so all of the concept behind it you are clarified now. Let's check what is the value over there. Value is being taken, fraction introduced, 49.4 minus 18.3 divided by 1.4 equals to, then it is this, it is 22.2 Newton is the force, which is the required for as the minimum force for it. The student could have lifted the rail by applying a vertical upward force of the handle. The force needed to lift the rail is different. Okay. Is different when the force is vertical compared with when the force is perpendicular to the rail. All right. Explain how minimum vertical force is needed is different. You don't need to include any further calculation. Okay. So I will say here that as we know, each force is applied by the student must cause the same moment about the pivot over there. Like if this is the main beam over there, where I say this is the pivot, if the student is exerting the force and it will have to exert the force Sam on the other side over there, and equal in magnitude they should be. And when the force is vertical, the component of the force is perpendicular to the rail of must be Sam over there. So he is saying if F is vertical, as a vertical component is available, then the perpendicular component of train or rail over there, vertical component of our rail over there will also be equal, will also be same over there. Or when the force is vertical, the perpendicular distance from the line of action of force to the pivot is less over there. So we can say moment arm will be less in that case. So these are the two reasons which I want to explain. But if the same magnitude of force is applied, then the moment of the force is less. And so when the force is vertical, the force is needed that will be greater. That is explanation you can write in your own words over there. Okay, this is the last question of this paper where he is saying a skydiver jumped from an aeroplane over there. Okay. The initial velocity of the skydiver is 0. U is equal to 0. Okay. And then he is saying that during the first 1.5 seconds, the skydiver moved a vertical distance of 11 meter. So it is T, this is S. And air resistance may be considered negligible if the mean acceleration of skydiver is 0.95 g. Deduce whether the air resistance acting on the skydiver was negligible during the first 1.5 seconds. So I will have to go for acceleration calculation here. Then I will say that S is equal to ut plus half at square. Let's check what he is saying over there. I'm going to make A as a subject over there. S is 11 is equal to 0 multiplied by, because initial velocity was 0 over there, multiply 1.5. So it will become 0 plus 1 by 2 into A I want to calculate, and T square, T is 1.5 square. So I will say here 22 divided by 1.5 square. So it will be 22 divided by 1.5 square equals to this, equals to 9.77. 9.77. Now, if I want to take its ratio according to the original value, then I will say here I will have to take the ratio of both of them if I want to calculate how much the air resistance is involved or not. Then 9.77 divided by 9.81 divided by 9.81 equals to this, equals to 0.997. So it is 0.997, means only there is a variance of 3% is available over there. So I will say here is some calculated values of A with 0.95 G, and we can easily say that A should be taken as 9.78, will be having approximately 99% accurate value over there. Okay, what is he saying in the next part? He is saying that the displacement time graph for the skydiver between jumping from the aeroplane and opening his parachute is shown. Okay, this is shown. Sketch the velocity time graph. Okay, sketch the velocity time graph on the axis below the skydiver between the jumping from the aeroplane and opening his parachute. So it will be a curved line starting from 0 with negative gradient over there. So I will say it is like this. Okay, and the gradient is decreasing in magnitude. So it is decreasing in magnitude gradient because it is above the line. It will be negative gradient over there in magnitude, and then a horizontal line for from the 12 second. It will be a horizontal line from 12 second onward. So it will be here the parachute is opened and the velocity is vertical component is constant over there. So this was your part B. What is he asking in part C over there? After jumping from the aeroplane, the skydiver accelerated and then reached a terminal velocity before opening the parachute. Explain how the energy conservation applies to the skydiver before opening his parachute or like that. Here I will say that as he coming towards Earth, so height is decreasing, and we can say gravitational potential energy is decreasing. What more concept? Because he is asking for 4 marks over there. Gravitational potential energy is decreasing, and we can say while accelerating, kinetic energy is increasing, because this is increasing because it is accelerating, and it is freely falling by having the constant acceleration over there. And work is done against air resistance over there. So remember that always, air resistance over there. And we can say energy is dissipated due to work done against resistance at terminal velocity. Kinetic energy and gravitational energy is dissipated due to work done against the air resistance. So all the gravitational potential energy and kinetic energy both are being taken, and both should be used in the form of complete energy over there. Okay. Is it finished? I think so. No, this is the last part. The skydiver opened his parachute and his speed changed. After a time, he reached a terminal velocity. Explain how the force on the skydiver caused his acceleration to vary after the parachute is opened. So remember that upthrust plus air resistance, upthrust force plus air resistance force. Upthrust is because of air resistance force. And I will say here, as the upthrust force and air resistance force will both become equal to weight, then we can say the drag force is becoming equal to weight, then a resultant force will equal to 0. Resultant force, because if I am going to subtract this weight on the other side, will equal to 0. And we can say acceleration is 0, and terminal velocity, which is a constant velocity, has attained over there. So this is the way how we can say a parachute can be going to work to show over there. This was our whole topic of this paper, and it was around about 20 questions in this paper. 10 were MCQs and 10 were the structured questions over there. And I think so you have completely got what the solution I tried to explain for you. Thank you so much for watching this video. Kindly subscribe my channel if you didn't have till now, and kindly share the video with your friends, so that and if you have any other paper solution, or you want any paper to be seen over there, I will share the video. Kindly comment on the video. Thank you so much. Allah Hafiz.